All right, I wanted to take a little time to take you through activity 3, and this is on page 2. So that's where I'm at right now. We're going to open up the simulation and we're going to look for more evidence to answer the investigation question: can substances change into different substances? So when we open up the simulation, what we're going to do is we're going to be in laboratory A mode. We're going to add calcium chloride and sodium carbonate. These are the two substances that were mixed together by Mrs. Hendricks in activity 2, and we're going to test those out to see what happens at an atomic scale to the atoms when they're mixed of the two substances, and also the properties. And we're going to see if the properties change. So, if you want to do this with me, you can click the simulation. And we're going to add those two substances. Okay, so we have to go find calcium chloride and sodium carbonate. What we're going to do is we're going to test these so that we mix them together. You can see they're being mixed together right here and combined. And then we get an atomic model to see what's happening to the individual atoms of both of the substances. We'll come back to that in just a minute. If you'd like to, you can kind of go back and rewind. But when you look at the atomic structure of these two substances, this is the calcium chloride, this is the sodium carbonate. Watch what happens as they bump into each other. Nothing at first, but right there is an exchange of some atoms. So we're going to take a look at what happened in the results. So these are the resulting substances, and let's just take a look at what we have. We have sodium chloride now and calcium carbonate. So if we go to the top and we review this, and we turn on the atomic scale and we view the properties, what we started with was calcium chloride and sodium carbonate. And this little arrow shows that when they were combined, we ended up with sodium chloride and calcium carbonate. So a couple things that you want to look for evidence here. We learned in chapter 1 that if we have different substances, those substances will have different properties. So as I look at what we started with, we had two white colored substances. We ended with two white colored substances. Started with two solids, ended with two solids. We had odorless solids to start with. We ended up with two odorless solids. Here's where the big differences happen. Melting point is a property, and you can see that of the two substances, neither one of the substances after we combine the two have the same melting point. So that is a property that changed. Therefore, we can be fairly certain that the substance changed. And same thing with boiling point. Even though we only had information for one of these, it seems to have changed. The other thing we can look at for evidence is, are the arrangement of the atoms that make up each of the substances the same before and after the mixing? And you can see that we had two chlorine atoms together with a calcium atom to make calcium chloride. When we look over in what are called products, after we combine the two, we don't see that same arrangement. Therefore, we must have a different substance after the mixing. Same thing with the sodium carbonate. We have two purples, three reds, and a gray. Afterwards, after mixing, we don't have that same arrangement of atoms. So that gives us another clue that we couldn't see in activity 2, that we have a brand new substance. So if you had a hard time with this, I'd like you to, you could rerun this if you want to, so you can look at this in more detail if you'd like. But I'd like you to try to answer the questions on activity 3, page 2, and then you could, or it might be page 3, and you can submit that.